Good morning, everybody. Today I can dilate lines centered at the origin by keeping the slope and multiplying the scale factor in B. So this is going to build upon a lesson we did earlier this year. So I'm going to kind of do a little review of that. So let's say I have a line segment. Let's call it, let's say we have A and B. A can be 3, 1. B can be 5, 3. And I want to, let's just type this out. Dilate AB by a scale factor of 2, centered at the origin. So, and again, this particular problem isn't on your sheet or anything. This is just something that I'm kind of using to develop this for you. So A is 3, 1. B is 5, 3. And I want to dilate it by a scale factor of 2, centered at the origin. So what I do is I count from the origin. Nothing seems to be working today, that's okay. So to get to A, it would be 1, 2, 3 to the right and 1 up. So do that twice. 1, 2, 3 right, 1. 1, 2, 3, 1. That would be my new point A. For B, 1, 2, 3, 4, 5. 1, 2, 3. Do that twice. 1, 2, 3, 4, 5. 1, 2, 3. 1, 2, 3, 4, 5. 1, 2, 3. And there it is. Now, there's a couple of things that I want to conclude from this. First off, let's write the coordinates of the new points. A prime is now 1, 2, 3, 4, 5, 6, 2. B prime is now 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6. Now, similarly to when we dilated shapes, if we were centered at the origin, we multiplied by the scale factor. And it's the same thing here. If I'm centered at the origin, I'm multiplying the scale factor by the coordinates. So with dilations, whether it's line dilations or shape dilations, we're always multiplying by the scale factor. Another thing I want you to recognize is that these two line segments are parallel. That will always be the case, and we know that parallel lines have the same slope. So when you do line dilations, the image is always parallel, which means the slopes are always the same. If you're centered at the origin, which we're going to do today, then we're going to multiply the scale factor and B. So when you're centered at the origin, whether it is a shape or a point or an equation, when you're centered at the origin, you're always multiplying. Now, in this case, we're never multiplying the slope. Since the image is always going to be parallel, the slope is going to always be the same. But the y-intercept, you would multiply by the scale factor. So to help you with this, let's get off of finance. Let's go to Schlansky.com. Let's go to YouTube. Now, the song incorporates a little bit more, what we're going to be doing in the next couple of days, but let's just hear the whole thing now. Geometry, line dilations. Oops. Let's Get some sound going on here. Line dilation, parallel, keep the slope. Center on the line, sub X and Y on the line. Same beat, off the line, different origin, multiply, scale, factor, and speed. Yeah. So it's a lot of extra stuff in this song because for this lesson, we're not going to be worrying about if the center's on the line. That's going to be the next lesson. So basically what you need to know from this lesson, is the slopes are always the same. And then origin, multiply, scale, factor, and B. We did a lot of talking. Now let's do some doing. These questions have come up in every single region. It's honestly a lesson that students struggle with, but if you know the song, you know the steps and the different types of questions, it's really not bad. Line dilation, parallel, keep the slope. No matter what, when you're dilating a line, you are keeping the slope. The slope of this line is 2, so the slope of my line is 2. The reason is, as we showed before, whenever you dilate a line, the image is always parallel, and parallel has the same slope. So, just turn my sound off. So, origin, multiply, scale, factor, and B. I write B equals KB for short. What that means is my new B is K, my scale factor, and the original B. When I multiply the scale factor in B, I get 18. Once I have my M and my B, I can use slope-intercept form. Y equals 2x plus 18. Line dilations, parallel, keep the slope. No matter what, when I see a line dilation, I keep the slope, so my slope is 2. For origin, multiply, scale, factor, and B. Once I have my M and my B, I'm done. So mathematically, there's really not a lot here. It's just understanding these couple of concepts. Line dilation, parallel, keep the slope. I never change my slope. My slope always stays the same. Origin, multiply, scale, factor, and B. My new B is my scale factor. I call scale factor K times my original B. So my scale factor is 5/2. My original B is -2. If you don't like fractions, use a calculator. 5/2 times -2 is -5. I have B, I have M. Once I have M and B, y equals mx plus b, y equals 1/2 x minus 5. Number 3, line dilation, parallel, keep the slope. Take about 5 seconds and write down what the new slope is going to be. My new slope is 4. Because my original slope is 4 and Line dilations, parallel, keep the slope. Origin, multiply, scale factor, and b. Scale factor is 1/2. My original b is 0. If there is no b written, then it's 0. 1/2 times 0 is 0. Y equals 4x plus 0, which is just y equals 4x. That'll be your answer. Now, notice how the original and the new one are the same. That's because the center of dilation is on the line. We're going to talk more about that in the next lesson, but that's kind of just planting a seed. The origin is on this line, and if you have a point that's on the line, the equation is going to stay the same. But again, we're going to do more with that later. I don't really feel the need to do much more with you. Why don't you pause, try number 4 on your own, and then unpause. Okay, now that you tried number 4 on your own, let's see if you got it right. Line dilations, parallel, keep the slope. Keep the slope. Origin, multiply, scale factor, and b. Scale factor is 5/2. My original b is positive 4. Use a calculator if you're afraid of that. Alpha y equals enter. I guess I like this 5/2 scale factor today. 5/2 times 4 is 10. I have m, I have b. Y equals negative 2x plus 10. All right. Let's just try number 7. It's got a little twist to it. And then after that, I'm going to let you practice on your own the rest of the period. The equation of line H is 2x plus y equals 1. Line M is the image of line H after a dilation with a scale factor. Line dilations, parallel, keep the slope. Well, the only problem here is I don't really have the slope right now because y is not by itself. So in order to get the slope, and we did this in previous lessons in this unit, we would need to get y by itself. So the slope of this line is negative 2. Again, you're hearing me sing a lot today. Line dilations, parallel, keep the slope. So again, you're going to have to get y by itself, put it into slope-intercept form before we can get the slope. And once we do, it's the same as the other ones. Origin, multiply, scale factor, and b. B is 4, m is negative 2, y equals negative 2x plus 4. So that's it. When you're dilating a line centered at the origin, the slope is going to be the same because the image is always parallel. And then again, if it's the origin, which this whole lesson is, we're going to multiply the scale factor and b. We'll talk about when it's not the origin in the next lesson. And why don't we just one more time hear our amazing song. With the volume on. Line dilation, parallel, keep the slope. Center on the lines of x and y on the line. Same b, off the line, different origin, multiply, scale factor, and b. All right, that's it. That's all I got for you for today. So again, I can dilate lines centered at the origin by keeping the slope and multiplying the scale factor NB. Your classwork/homework is to finish line dilation centered at the origin. Next lesson, we will see what happens when it's not at the origin. And I hope everyone has a great day.